apologize for the...
How's your day going?
Not too bad. Remember yesterday I gave you guys the original couple of steps for these. I told you the first one was given. Hey, Merry Christmas.
No, it's not even Halloween yet.
You know what? I was so PO'd last night, not because the Cubs lost. You know what I'm talking about, right? The Best Buy commercial with jingle bells going on.
Yeah.
I could not
I
believe it. I could not believe it.
This is ridiculous.
I looked at him I looked at my wife and I go, are you kidding me? I mean, I get it. It's the holiday season is where it's wonderful time of the year. Anyway, so this is why I went into teaching, not singing. That's where people spend exorbitant amounts of money, and they figure if they tell people about it sooner and sooner, they'll start spending money sooner and sooner. Personally, if I see that, I'm not buying it because it's annoying. Go away. Speaking of,
I got it.
eventually.
Wait, right now.
Nope. Given.
Go away.
So obviously, right off the bat, you've got a given statement. Secondly, I told you guys why are 9 and 11 add up to 180. I told you to write down the definition of linear pair. It's a very easy thing to use.
Yeah, we were.
Now, excuse me. Looking at the diagram, why are angles 11 and angles 14 equal to each other? What's the angle pair relationship?
Interior angles.
Alternate interior angles. Good. So you have to put,
Whatever the interior angles are congruent.
guys, you have to put this. You got to put that symbol in there.
Yes, sir.
Either put that symbol in or write out if two parallel lines are cut by a transversal, then blah. Well, just make the symbol. It's easier. Okay, got to put the symbol in, and then just write in alternate interior. Do I say congruent or equal in this case? Equal. Is it okay to switch between equal and congruency with those statements?
No.
Absolutely. Because if they're congruent, they're an equal measure. In this case here, they just went right to equality because their first statement was linear pair stuff. That's all. That's the only reason why they switch it. You see that from time to time, especially if you're dealing with supplementaries. It's kind of a quick way to do it. And then lastly, what's your last step? Substitution. Here's why it's not transitive. I know you saw this. You saw that, didn't you?
Yeah, man.
Bless you. Transitive. Guys, transitive is only going to be if something equals something, something equals something. There's nothing else put in there. Transitive doesn't occur if there's addition and subtraction built in. Okay? So this is substitution. It's not going to be definition of supplementary here because you're talking about those angle pairs. You're sending those things through. Okay? I think I'm doing all the. There's two more progressions we have to look at as we go through. Okay. Yes, sir.
It's like the final step.
Not necessarily. Don't always think that. Because sometimes it won't. Sometimes it is, sometimes it's not. Sometimes it's a change in congruency. Sometimes it's definition of a midpoint. Sometimes it's angle bisector. You know, it could be anything. Okay? Another real quick one. This one actually deserves its own progression at the end, and we'll talk about this here in a second. So in this case, you are given two parts. You have got parallel lines, as well as you're given that angles 1 and 2 are congruent. So we just write out that we have the given statement, and then we know that 1 and 2 are congruent. So I just mark it. Okay? After I mark that, then I go to the next statement. The next statement says that 1 and 3 are congruent. Well, why?
Is it if whatever it is, then
Perfect.
That's what I wrote.
If two parallel lines are cut by a transversal, corresponding angles are congruent. Because 1 and 3 are corresponding. Yes, sir.
do we have to do that?
Yes, sir. You have to. If you don't, it's wrong. Okay? So now, 1 equals 2, 1 equals 3. Why does 2 equal 3? Substitution. It's 1 is congruent to 2, 1 is congruent to 3, 2 is congruent to 3. It's a heart attack. They're not consecutive interior because they're not consecutive interior. And now here's where we have to throw a progression together. For this last one, you have to be able to do this. And this does show up from time to time. Take your sheet out real quick, and I want to show you something. It's a very common scenario. This is a very common scenario. Just like we've done in the past where we've said if two lines are perpendicular to each other, they create right angles. Then we say if right angles are created, then the two lines are perpendicular. You can do that, what's called a biconditional statement. If an angle is a right angle, it measures 90. An angle measures 90, it's a right angle. It means the same thing going forward and backwards. Well, it kind of goes along the same exact lines with parallel lines and transversals. So, past 2 days we've been talking about if two parallel lines have been cut by a transversal, you got alternate interior angles congruent, alternate exterior angles congruent, consecutive angles congruent, or not consecutive, corresponding, and then consecutive interiors are supplementary. Well, if you say that in reverse, if you have alternate interior angles congruent, then lines are parallel. If you have corresponding angles congruent, lines are parallel. You can say it going either way. So what happens here is you can do this. If alternate interior angles congruent or alternate exterior or corresponding or consecutive supplementary. If one of those four happens, then you can say that your lines are parallel. Just like if our lines were parallel, one of those four things happen. Well, we can do the other, we can go the opposite. If one of the four things happen, then lines are parallel. Okay? Okay, and I'll show you how this, there's really no one size fits all for how you fill that in with a reason bank, per se, because you're going to have, once you're able to show that one of those angle pairs occur, you know, in the example we're doing right now, we have, I think, corresponding angles right now. So now we have corresponding angles on that, what is it, 2 and 3? Well, if you have corresponding angles that are congruent, then that means the two lines that are created there are parallel. That's all you have to say. So in the proof part that we just looked at, I would write the following. Since we have these guys we know are corresponding, we can say corresponding angles are congruent, so lines parallel. Or not so, we should say then lines parallel.
So if we got that, like, not.
Well, you didn't really know what to say yet. That's why. Okay, and I knew we ran out of time to get to that part, and that's kind of like the very, very last bit of what I'm going to be going through this week. Was how do you show that lines are parallel? Well, in order to show that lines are parallel, you got to get one of those angle pairs to happen. Yes, ma'am. Yeah. So if any of those four things occur in a proof, you can say that those lines are parallel then. That's all it is. That's all it is. So you're utilizing the idea that you've got one of those angle pairs, then the lines are parallel. Just like we did the past couple days where if you had the parallels, then you can say what those angle things happen. That's all. What's up? We're going to add into it. Yeah, we'll add to it. Thank you. Roll my eyes. Do it. Throw a piece of stuff on the floor. Throw stuff on the floor, put stuff on the answers on the ceiling. That would be pretty funny. We okay? Does that make sense how that works itself out? It's a very easy step, okay? Because we'll do a little bit more of the proof stuff today. Tomorrow, I'm going to review some of this with you and show you how that also works algebraically. The algebra of it is ridiculously simple. Yes, ma'am? I do have a few. I got to take them out. I have so many people coming through these couple of days, I can only restrict to a couple at a time. I don't have enough space. Okay? So that's what we got with these. All right? Let's go to the next one. Ladies and gentlemen, I'm really trying to get through as much of this as possible. So please.
Mr. Murphy, can I use the restroom?
Yeah.
Like, okay, I haven't all this week.
It's only Wednesday.
It's only, okay, really.
So on the fourth one, this one should have been a really quick one. There wasn't much to it. I think it was just a quick substitution step, and that was about it. Now, when you're doing these things on your own, trying to figure out where to go with it, always start with your given. Obviously, G parallel to H. And angle 1 is congruent to angle 5.
We put that in the same.
Yeah, that's what
If you want, I don't care. I hardly ever do, just because there might be something else I can say about something. That's all. Because more often than not, that's when you forget something. So now we stop and look and see what they want us to do. They want us to prove that 5 and 3 are the same. Well, right now we have 1 and 5 being the same, and we know that G and H are parallel to one another, which means I need to look at some sort of other relationship. Well, I've got nothing else to talk about with 5, but I do have something I can do here with 1. What can I say about the relationship between 1 and 3?
They correspond.
They correspond. They're corresponding. So what are they then? They're congruent. So now I can just say that 1 and 3 are congruent. Oh, crap, the thing here.
I did 2 and 4.
What's that?
I did 2 and 4.
I don't think it's not going to get you anywhere, though.
Yeah, I know.
Did you have to do another step of 1 and 3 then?
Yeah.
That's fine. It's no big deal if you have it in there. It doesn't hurt. It's just an extra step.
I just did mine. I don't know why.
It's okay. It's okay. There are more than one ways to write these things out. So I know that those two guys are congruent. Okay? 1 is congruent to 5. 1 is congruent to 3. What do you know about 5 and 3 then?
They have to be congruent
Why?
to each other.
Done.
Yeah. But that's what you meant about because yesterday we were talking about the one is on the topic.
Yep. And you're done. Because you're given 1 and 5, lines are parallel, so it gives you 1 and 3 because corresponding angles are congruent. And it's just a substitution step saying that they're congruent to each other. That's all it was. 4 steps. 5 if you went crazy.
Crazy.
All right?
Nope. Never heard that song before? Okay.
All right? Now, on number 5 is where things get weird. Okay? 5 is where things get weird. Anything good? All right. 5 is where things get weird, and we're going to have to add something to our sheets here. We've talked about this step, but we've never had to use it in anything. We've used it algebraically, but nowhere else. Lousy. Look. So, in this case, we have our parallel lines, G and H, so we start with that. There's your given. We mark it. Okay? After that, you now know that 6 and 3 are supplementary. Okay?
Is it because if you have a transversal through a parallel,
6 and 3 are supplementary just because it's given.
well, yeah.
Yes, ma'am. What are you going to say? You can do that, but there's an easier thing to do. That's one of the ways to go about it. Let me see what else you did. Now there's, oh, okay. Now, ladies and gentlemen, there are multiple ways of going about doing this proof. You could go ahead and go via supplements, because if you say that 6 and 3 are supplementary, then you can say 6 plus 3 is 180. Do you agree with me on that?
Sure.
Now, then you'd have to go back and look at the two parallel lines cut by a transversal. Well, what other two angles had to add up to 180? 2 and 3, because they're consecutive interior. But then you'd have to do a lot of substitutions. But it would work, it would just take you quite some time. But there was another thing that we talked about. We talked about this scenario earlier this week. We talked about what are called congruent supplements.
Did you already write that down?
No, we did not. And congruent complements. We talked about congruent supplements and congruent supplements and congruent complements. Congruent supplements were two angles that were supplementary to the same angle, which made them congruent to each other. Now, we showed this a couple of different ways. The easiest way was, if I just do this, say this is 160 degrees, that has to be 20. They're both supplementary. You agree?
Yeah.
If I draw it back down this way, this is also 160 degrees, which means it's supplementary to 20, which means these two have to be the same angle. Okay? That was one way to show it, kind of by having vertical angles. Well, the other way that we could show it is just to draw them all out separately. They don't have to be sharing the same vertex. You can have your 160 degree angle here, another 160 degree angle here, and then a 20 degree angle here. 160 and 20 are still supplementary, correct? 160 and 20 are still supplementary for the other one. So no matter what, if two angles are supplementary to the same angle, those two angles are the same. And it goes the same way with complementary. But complementary just add up to equal how much? 90. So what'll happen, darn it, what did I say something important? So what'll happen is, I want you guys to remember this definition. If two angles are supplementary or complementary to the same angle, would you write that for me, please? And then, so if two angles are supplementary or complementary to the same angle, then those two angles are congruent to each other. It's the same definition, just one of them says supplementary, the other one says complementary. It does the same thing. Now, what'll happen in a proof though, it's not always going to be given to you that you can do this. It's like a trick. So, there's no like statement that you can come up with, but there's always going to be some reason that you can say that two angles are congruent to each other because of the definition of congruent supplements, or it could be the definition of congruent complements. And I'll show you in this proof why I would choose to use that definition as opposed to setting things equal to 180 and doing a lot of substitutions. It'll work, it just takes a little bit longer to go through there. Okay? Ooh, excuse me.
No, don't continue.
Are everything run out of squares?
I don't think so. I think I make it to be, what are these, 24 of them? I believe it's 12 and 12. I think we want to be pretty darn close. If we do run out of squares, I have a stapler. Convenient, right? When all else fails, staple. All right, so going back to this then, if I look back at my parallel lines, do I have a set of angles between angles 1, 2, 3, and 4 that are supplementary? Which ones? Not all of them, but I have 2 and 3. I can say that angle 2 and 3 are supplementary because they're consecutive interiors. So if two parallel lines are cut by a transversal, consecutive interior angles supplementary. So now do I have two angles that are supplementary to the same? Yeah. 6 and 2 are both supplementary to 3. So 6 and 2 are both supplementary to 3. What do you know about 6 and 2?
They're supplementary. Yeah.
They're one of those. Which one is it?
Supplementary. I
No.
mean, no.
They're congruent.
I couldn't think of it. I kept thinking complementary.
So as you go through one like that, yes, you could have gone through and done the whole 180 and done a bunch of substitutions. But knowing the definition about congruent supplements is key. And there you go. And that's how you'd write it. You're done. Yeah, it's 4 steps. 4 steps or something like that. It's real quick. Okay?
3 if you combine the hidden.
Yeah, but try not to do that.
Yeah.
There's reasons we don't. So you don't mess something up. Okay? That's how that one works. Does that make sense? Congruent supplements is a nice little trick. It's a nice little trick. Okay? Let's do this. Take a minute or two, and I'd like you guys to do number 7. It's on the next one over. I want you to try and go through number 7.
Number 7. When all else fails, what? Staple. Okay. I told you I was gonna.
Yeah. Come on, guys, let's go. I want you to.
Mine was kind of like,
Show me the way with some
I
work.
think I did it right.
So you need to show that 2 and 7 are going to be 180. Okay. Now, the easiest thing to do is to start with something that already equals 180. For example, which ones?
I
3.
used angle 7 and angle 6.
Angle 7 and angle 6 equal 180? Why?
Because they're linear too.
Perfect. I can say this. Angle 6. Hey, don't erase what you got. I'm sure there's trust me, there's more than one way to do this. There is. Just hear me out here. Angle 7 and angle, was that 6?
Yeah.
Yeah, 6 are 180 because they are a definition of a linear pair.
Then,
Okay. What'd you do next?
I put angle 6 is congruent to angle 2, and then the definition of the transversal line, with corresponding exterior angles, right?
Okay. It's not corresponding to x here, they're just corresponding.
Oh,
Now, what she said was right about angle 6 congruent to angle 2, but what should I say between them here?
Equals.
Equals. It's because we've already talked about it being equal. So now I can, and you're right, that's all it is. It's one fast step. Because you know that these two guys have to form a linear pair. Well, not only do they form a linear pair, well then these two guys are congruent to each other because corresponding angles. So if two parallel lines cut by a transversal, corresponding angles are congruent or equal. And now you're done by just throwing a substitution. 4 steps.
That's how I did it.
I had mixed those two.
There are so many ways to do it. When I first saw this problem, I tried to set it up in terms of congruent supplements, and it was like almost 9 steps. It works, but you don't need it to go that crazy. You could have done it where you had 2 things that added 180, and then done a double substitutions because of 7s and the 7 and 7 and 3 are the same, and 6 and 2 are the same. So you could have done stuff like that as well. But this method right here is the fastest. Either 7 and 6 are a linear pair, or 3 and 2 are a linear pair, and then just do a quick substitution with the corresponding angle. That's it. It's angle pair relationship proofs should be the easiest ones that we look at. Quite honestly, I'm not lying. They're so unbelievably straightforward. There's not a lot of ambiguity to it. There's no, I don't know what to do next, because it's just a matter of figuring out what angle pair do you have and looking at your diagram. Really, that's what it boils down to being. Okay. What does 8 look like?
Hard.
Oh, it isn't. You just give them 2 parallel lines. Really, we put letters in there. Oh, it's super easy.
Oh my god, you got
Work on 8. Work on 8. Actually, wait. We're almost done here, aren't we? Let's do. Let's do 8, 9, 10, 11 for tonight. We'll do these next 4 for tonight. Now, I will say one thing. For numbers 9, 10, and 11, for numbers 9, 10, and 11, you're probably going to have to use. No, not a calculator. You'll probably have to use some form of this last progression that we did, about showing if you had the angle pair relationship and the lines are parallel. You're going to use that probably as your last step, because it wants you to prove that lines are parallel. For 9, 10, 11, the last 3. You're getting better at it. Seriously, trust yourself, man. Trust yourself. It's,
I wish I knew the answer to everything.
well, it tells you what it is.
I wish I was Einstein.
You work with what you're given is, and you start trying to look at the diagram. You're using parallel. Now, I've said this before. It's one of these things that
I just love moms.
it's not so much you guys have to be yelled at to figure out a proof to get a job, but you have to be able to put together a valid argument. You have to be able to show why something works.
Hold on.
Yeah.
What did you even say that? So basically the rest.
Yeah, that'd be 8.
It's like easy and hard.
Yeah, hey guys, I didn't realize the diagram got a little cut up there. On number, which number is that, Spora? That was what? 8? On number 8, there should be, this is A. This is AB, that's EC. Okay?
A?
Yeah, it's missing an A right there, so that way you know that that's the A value. Okay? Yes, ma'am. I think the rest of them are really easy. I mean, quite honestly, most of these things are 4 steps. It shouldn't be any more than that, okay?